Okay, in this video we're looking at standard form and an introduction really to what standard form is, and specifically in this video we're looking at writing numbers in standard form and writing them as ordinary numbers, and you'll see what that means in a second, but let's just crack on into the video. So what is standard form? What is the crack all about? So let's just say we're given a statement like this, which said the Jurassic Age began that many million years ago. And I had to think a little bit there because actually looking at that number straight away, it's pretty hard to compute what that number is unless you really think about it, because if we do think about it, well, we can go and put some commas in there every three numbers from the end, and we can see that this number is 199,600,000 years ago, which is a really, really big number. And actually it isn't particularly easy just to read from the top of your head without kind of going through it and putting in the commas. And this is the motivation for having a standard form. If you're given a really, really big number like we are here, or you're given a really, really small number, we can write it more simply using something called standard form. And this is massively used in a lot of fields. You know, if you do something like engineering in the future or science, okay, where you're dealing with often really big or small numbers, standard form is going to be a really useful friend or tool to you to help you do this. So this is the motivation of standard form, to write really big and small numbers in a specific form. What is that specific form? This is the form for standard form. So let's kind of go through this. Standard form is where you've got a number, first of all, which is between 1 and 10, but not including the number 10. So here they've gone for 4.2. It could have been 2. It could have been 5.999, for example, but it must be between 1 and 10, but not 10. You then times it by the number 10, and it's always times by the number 10 to some power, where this power or index can be either positive or negative. You'll see later, if it's positive, it's going to be a massive number, and if it's negative, you're going to get a really small number. But it must be an integer. Okay, integer meaning, okay, this word means whole number. So that power, it must be a whole number. So you can't have like something to the power of 2.7, for example. So I would definitely make a note of this. That's going to be really, really important. And then we can move on. Okay, before we actually get into, because the process that I teach my students this, it is really quite simple, but I think the understanding, as always, in maths is just really, really important. So I've got two examples here that look very similar, but there is a slight difference. Okay, so both of these numbers here are written currently in standard form, and I want to see how you can get to write these numbers in standard form as just normal numbers that you see, so ordinary numbers. The first one, we've got 5.3 times 10 to the power of 3. Again, this is currently written in standard form because you've got a number between 1 and 10. You're timesing it by 10 to some power, which is positive, and it is an integer. So this is currently in standard form. But let's break this down. Well, we could write this a little bit differently. This could be written as 5.3 times by 10 cubed. We know from our laws of indices means times by 10, timesing it by 10, and timesing it by 10. So literally we're taking 5.3 and we're timesing it by 10 3 times. So we're going to get a really big number at the end of it. If we go through this one by one, so we take the 5.3, we times this by the first 10. So I go and times this by 10. Well, 5.3 timesing it by 10, you're going to get 53. I then take 53, I times it by another 10. So I take this number, I times it by 10 again. 53 times by 10 is 530. If I take 530 and times it by another 10, okay, so times this by 10 again, we're going to get 5,300. So you can see, okay, initially 5.3 times 10 to the power of 3, this thing here, this is written in standard form, okay, and then we get, and this is exactly the same thing as 5,300, okay, and this is written at what we call as an ordinary number, and that just means numbers that you just see in everyday life. So an ordinary number is just something that you're used to seeing, like 5,300 in this case. But this is what is going on behind the scenes with standard form. So if you're timesing by a positive power, you're timesing by 10 by how many times you see that number. So in this case, 3 times. Timesing it by 10, timesing it by 10, timesing it by 10. So you end up with a really, really big, it's not massive, but it's a pretty big number in this case. Now over here, we've got 5.3 times 10 to the power of negative 3, which is slightly different. Okay, and this one's a bit trickier to go through, but we've got the knowledge to understand this, so let's see what is going on here. So we can write this. We know, first of all, that 10 to the power of negative 3 from our laws of indices, okay, if you've got a negative power, it's always 1 over that number, which is 10, and you raise it to the power that is given, which is 3. So 10 to the power of minus 3 is the same thing as 1 over 10 cubed. So this here, 5.3 times by 10 to the power of negative 3, we can write as 5.3 over, because this 1 is effectively being times by the 5.3 to give you 5.3. And then 10 to the minus 3 is 10 cubed, which is 10 timesing it by 10, timesing it by 10. So this here, 5.3 times 10 to the power of minus 3, you can rewrite it to look like this. And then this can help us understand it, because we're seeing here that you're dividing by 10 3 times. So you're dividing it by 10, dividing it by 10 again, dividing it by 10 again. And you will see you get a really, really small number at the end of it. So if we go and do this, 5.3, and we divide it by, because here this means divide by that first 10, 5.3 divided by 10 to begin with, so this first 10, okay, we're going to get 0.53. If we then go and divide by 10 again, you're going to see we're going to get an even smaller number, so 0.053. Then we go and divide it again by 10, we're going to get 0.0053. So you can see, right, this number 5.3 times 10 to the power minus 3, again in standard form, and then because we've got a negative power, we end up with a tiny number, 0.0053. They both mean exactly the same thing, so this and this have the same value. You can put it in your calculator or type it in. They mean the same thing, but just this is written as an ordinary number again, but just the number is really, really small this time. So this here, again, is what we just call an ordinary number. Okay, just numbers that you're used to seeing in everyday life. So that's the understanding of standard form when you see a positive and a negative power. But in reality, right, when we go through the questions on this, we just kind of follow a bit of a process. But understanding stuff is really, really important. So we'll go through some my turn, your turns. There's 2 lots of my turn, your turns, and then we'll go through some questions you can go through at the end, and that will be it for this video. So this question says, write the following. So these currently are in standard form, okay, because it's a number between 1 and 10 times by 10 to some power. We want to write these as ordinary numbers. And again, this just means you want to write it as a number that you see in everyday life. Okay, we're not going to go through that process of timesing it by 10 4 times. It takes too long in reality. The way that we do this is we take our number, which is 2.3, and you can think of it as your decimal point moving this many places forwards. 4. It doesn't actually move in reality. Your number is just getting bigger by 10 to the power 4, but this is the way that I just think is easiest to go through. So your decimal point is here, and we're going up by 1, 2, 3, 4 spaces up to here, because your power is to the power of 4. And then you fill in these gaps here with zeros, 0, and a 0, and that is it. So 2.3 times 10 to the power 4 we can write as 2, 3, and then 3 zeros, 0, 0, 0, so 23,000. So 2.3 times 10 to the power 4 is the same thing as 23,000, okay? And that is your answer. There we go. Okay, the one below, again, just double check, is it currently in standard form? Yes, it is. Your first number is between 1 and 10, timesing it by 10 to some power again. Again, with this, you just take your number, which is 1.76734. You take your decimal point and you move it forwards by what the power is of that index, which is 4 again. So 1, 2, 3, and 4. So your number now, your decimal point is moved up to here. It hasn't actually moved in reality, but you can just think of it like that for the time being. So we get 1717673.4. So that is your number. So these two things mean exactly the same thing, but just again, this number I'm highlighting here is written as an ordinary number. So 17,673.4. Okay, so what you can do now is you can pause the video, you can try those two yourself, and then we can move on to the negative powers. Okay, so hopefully you've had a go at those. Let's go through these two. So again, your first number is 9.3. You're timesing it by 10 to the power of 3. So your point is moving up by 1, 2, 3 spaces. There we go, it goes there. You fill in these gaps with zeros. So we get 9, 3, 0, and then 0. If you wanted to, right, you could write 0.0. Again, you don't need to at all, because these two things mean exactly the same thing. So 9,300, it is your answer. So again, 9.3 times 10 to the power of 3 has exactly the same value as 9,300, just this one is written as an ordinary number. Okay, good. Your next one, we've got 9.3563. You're timesing it by 10 squared, so you're moving your points by 1, 2 spaces to go and put it here. So we're going to be getting 935.63. That is your answer. Perfect. If you got those two correct, that is really, really good. These are fundamental skills to have with standard form. Okay, and then we can move on to the negative powers. So these ones very, very similar, but this time you can see we have negative powers in the questions. Right, let's begin to look at these two. So the first one, we've got 3 times 10 to the power of negative 3. Again, you write out your number, which is 3. 3 has a decimal point after it, which is here. You can't see it, but you don't write it as 3.0, but 3.0 and 3 mean the same thing, but that is where your decimal point is, and it's going back by 3 spaces, and it's back because you've got a negative power. So we're going back by 1, 2, 3 spaces to go back to here. And again, you fill in these gaps here with zeros. So we write our number as 0.003. But just this time, you could, I mean, it's a bit clumsy to write your answer like that. If you see something like 0.003, really we mean 0.003. Like if you say 0.5, it means 0.5 in the same way that 0.003 means 0.003. Okay, so this is your answer in this one. So you can see this time you've got a negative power. Okay, 3 times 10 to the power of negative 3 has the same value as 0.003, which we can see, okay, it's written as an ordinary number, and we can see more clearly this time that this is a tiny number, which is nice. Our next one, we've got 4.18 times by 10 to the power of negative 3. Again, you go back by whatever this power is, which is minus 3. So your decimal point, it isn't moving, but you can just think about it like this for the time being. It's going back by 1, 2, 3 spaces. You fill in these gaps here with zeros. So we get 0.00418. But again, you know, if you're writing 0.00, you really want 0.00418. That is your answer for this one. Okay, a couple of your turns there, and then we can try some examples on the next slide. So, write the following as ordinary numbers. Again, just check, are these in standard form? Yes, they are. Numbers between 1 and 10, good. Times by 10 to a negative power, which is good. And your number here is going to be 9. There is a point here which you can't see, and you're going back by 4. So you're going back by 1, 2, 3, 4 spaces. We put in a point here. We fill in these gaps here with zeros. So we're going to be getting 0.0009, but again, we write it as 0.0009, and that is your answer for this one. Okay, so you can see it's a really small number. There we go. We've then got 4.56 times by 10 to the power of negative 4. Again, write out your number, which is 4.56. You're going back again by 4 spaces, so back by 1, 2, 3, 4. There we go. 1, 2, 3. Zeros go in there. So it's going to be point, and then 0, 0, 0, 4, 5, 6. But again, we write the 0 at the front of it. There we go. Brilliant. There we go. Okay, if you got those two correct, that is fantastic. You can then try these 4 questions, pause the video, and I've just mixed up these in different orders just so you can really test your understanding. If you get all of these correct, then you're definitely good to go with converting from standard form into ordinary numbers. So all of these numbers here are currently written in standard form, and I want you to write them as ordinary numbers. So let's go through and we can rewind to the end to go and see the answers. The first one, okay, just think about it. Is it going to be a big or small number? It's going to be a small number because you've got negative power, and your first number is 9.7. And we're going back because it's a negative power by 1, 2, 3 spaces. You put your point here, you fill in the gaps with zeros. So it's going to be 0.0097. We write it as 0.0097. There we go. That is your first answer. Good. Top right, we've got 3.297 times 10 to the power of 3. Again, it's going to be a big or small number. It's going to be a big number because you've got a positive power, and your number is 3.297. And we're going forwards by 1, 2, 3 spaces up to here. So it's going to be 3297. Okay, you could go and write the point in there. You don't need to, because if you did write the point in there, you would be writing a bunch of zeros afterwards, which you don't need to write because it means the same thing as 3,297. So that is your answer. Brilliant. If you got that, then good. Very good. We can move on to the next one, which is this. Again, it's going to be a really small number. You've got a negative power. So we've got 1.615 times 10 to the power of negative 5. So going back by 1, 2, 3, 4, 5 spaces. It's going to be 0, 0, 0, 0. So we're going to be writing it as 0, 0, 0, 0, 1, 6, 1, 5. Just be really, really careful when you do this, okay, that you're writing it carefully because it's easy to miss off a 0. So just be careful with that. Okay, and there is your answer. We've then got 3 times 10 to the power 4. And again, it's going to be a big number because you've got a positive power. So it's going to be 3. Your point is after that 3. So up there, we're going up by 1, 2, 3, 4 spaces up to here. You fill in these gaps with zeros. Okay, and we're going to be getting 3, 1, 2, 3, 4, 1, 2, 3, 4 zeros. So 30,000 is your answer. Brilliant. There we go. Okay, if you just fast forward to the end of the video and you've got all of those correct, well done. That is brilliant. That is something else that you can do. Okay, just be really careful when you do this. You write things out neatly. You take your time with it. You don't rush it. Otherwise, it is easy to make mistakes with it. Okay, thank you for watching.